There appears to be a situation involving the electrical service for a press box at a stadium. There are three structures involved, namely a concession stand, a ticket booth, and a press box. The concession stand is where the main service entrance is located. It was understood that the old press box was powered from the main service at the concession stand. Now, a new service entrance has been installed at the press box, including a meter base. A person associated with the league questioned the need for a meter base at the press box because there was already one at the concession stand. When the main was turned off at the concession stand, it did not disconnect the power to the press box. A separate 150 amp disconnect was found about 20 feet from the concession stand, and this disconnect is feeding the conductors for the press box. Key questions arise. Firstly, where is this 150 amp disconnect being fed from? Secondly, how is the supply for the press box metered if it's not from the main service? And thirdly, the commercial rate for a separate service is claimed to be too expensive. It is recommended to contact the power company, explain the situation to them, and request assistance in determining the source of the supply for the press box. They may have records or can dispatch a technician to investigate. If the power company cannot help, the next step is to trace the source. You may need to trace the conductors from the 150 amp disconnect to their origin. It's possible that they connect to another service entrance or a transformer. Also, it is important to involve the league. Communicate your findings to the league officials and ask for their help in clarifying the situation. They may have knowledge about the electrical system that you do not. It is important to ensure that the electrical system is safe and compliant with regulations. Seeking professional assistance if necessary is recommended. To address the problem systematically, firstly, gather all available information about the existing electrical installations. This includes any existing electrical drawings, permits, or past inspection reports. This documentation can provide valuable clues about the original design and any subsequent modifications. Secondly, carefully inspect the location of the 150 amp disconnect switch relative to the concession stand, the press box, and any other nearby structures. Look for any underground or overhead conduits or cables that might connect the disconnect switch to a power source. Pay attention to the size and type of conductors used, as this can provide hints about the voltage and current capacity of the circuit. Thirdly, use a multimeter or other appropriate test equipment to verify that the 150 amp disconnect switch is indeed supplying power to the press box. Measure the voltage and current at the disconnect switch and at the press box to confirm that they are consistent. Also, check for any voltage drop along the circuit, which could indicate undersized conductors or loose connections. Fourthly, if the power company is unable to provide immediate assistance, consider using a cable locator or tracer to follow the conductors from the 150 amp disconnect switch back to their source. These devices emit a signal that can be detected along the length of the cable, allowing you to trace its path even if it is buried underground or concealed within walls or conduits. Fifthly, if you suspect that the 150 amp disconnect switch is connected to a transformer, try to identify the transformer and determine its voltage and kVA rating. This information can help you understand the capacity of the circuit and whether it is adequate for the press box load. If the transformer is located on private property, you may need to obtain permission from the property owner to inspect it. Sixthly, if you are unable to determine the source of the power supply through visual inspection or tracing, consider contacting a qualified electrical engineer or consultant for assistance. They have specialized knowledge and equipment that can help you diagnose complex electrical problems. The electrical engineer can perform load calculations to determine the electrical demand of the press box. This involves adding up the power requirements of all the electrical equipment that will be used in the press box, such as lighting, heating, air conditioning, and electronic devices. The load calculation will help you determine the appropriate size of the service entrance, conductors, and overcurrent protection devices. Also, the electrical engineer can conduct a short circuit study to determine the maximum fault current that could flow in the electrical system under abnormal conditions. This information is needed to select overcurrent protection devices that are capable of safely interrupting the fault current. The electrical engineer can also assess the grounding and bonding of the electrical system to ensure that it meets the requirements of the National Electrical Code (NEC) and other applicable standards. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. Furthermore, the electrical engineer can review the electrical plans and specifications for the press box to ensure that they comply with all applicable codes and standards. This includes verifying that the wiring methods, materials, and equipment are suitable for the intended use and that the electrical system is designed to provide adequate capacity and safety. The electrical engineer can also perform an arc flash hazard analysis to determine the potential for arc flash events in the electrical system. Arc flash events are dangerous electrical explosions that can cause serious burns and other injuries. The arc flash hazard analysis will help you determine the appropriate personal protective equipment (PPE) that is required for working on or near energized electrical equipment. Additionally, the electrical engineer can provide guidance on energy efficiency measures that can be incorporated into the electrical design of the press box. This could include using energy-efficient lighting appliances and HVAC systems. Implementing energy efficiency measures can help reduce the operating costs of the press box and minimize its environmental impact. After the power source issue is resolved, ensure all wiring and connections meet electrical code requirements. This includes proper wire sizing, conduit usage, and secure connections. Also, verify the grounding system is correctly installed and bonded. Check the voltage drop to ensure it is within acceptable limits. If the distance between the power source and the press box is considerable, voltage drop can be a concern. Use appropriately sized conductors to minimize voltage drop. Furthermore, label all electrical panels, disconnects, and circuits clearly. Proper labeling helps in future maintenance and troubleshooting. Provide detailed documentation of the electrical system, including panel schedules, wiring diagrams, and equipment specifications. This documentation is invaluable for future reference and maintenance. The documentation should include the location of the 150 amp disconnect, its source, and the path of the conductors to the press box. Also, make sure that all electrical work is inspected and approved by the local electrical inspector. Obtain the necessary permits and schedule inspections at appropriate stages of the project. Moreover, consider installing surge protection devices to protect sensitive electronic equipment in the press box from voltage surges. Surge protection devices can help prevent damage to computers, audio equipment, and other electronic devices caused by lightning strikes or other electrical disturbances. To enhance safety, install ground fault circuit interrupters (GFCI) in areas where electrical outlets are located near water sources, such as sinks or restrooms. GFCI can help prevent electrical shock hazards by quickly interrupting the circuit if a ground fault is detected. Furthermore, provide adequate lighting in the press box to ensure safe working conditions. Install sufficient lighting fixtures to provide adequate illumination for all tasks performed in the press box. Also, consider using occupancy sensors to automatically turn off the lights when the press box is unoccupied. To improve energy efficiency, install a programmable thermostat to control the heating and cooling in the press box. A programmable thermostat allows you to set different temperature schedules for different times of the day, which can help reduce energy consumption. Moreover, consider installing a submeter to measure the energy consumption of the press box separately from the rest of the stadium. This will allow you to track the energy usage of the press box and identify opportunities for energy savings. Also, provide adequate ventilation in the press box to prevent the buildup of heat and humidity. Install exhaust fans or other ventilation equipment to ensure that the air in the press box is properly circulated. The conductors are 1/0 conductors and are 3-wire. It is important to verify the ampacity of the 1/0 conductors to ensure they are adequately sized for the 150 amp disconnect. Refer to NEC Table 310.16 for the ampacity of conductors based on their insulation type and temperature rating. Also, check the overcurrent protection devices to ensure they are properly sized and coordinated. The overcurrent protection devices should be sized to protect the conductors and equipment from overloads and short circuits. Perform a coordination study to ensure that the overcurrent protection devices will trip in the correct sequence under fault conditions. The coordination study should take into account the available fault current, the conductor ampacity, and the characteristics of the overcurrent protection devices. Furthermore, inspect the condition of the conductors and connections to ensure they are free from damage or corrosion. Replace any damaged or corroded conductors or connections. Also, verify that all connections are properly tightened to prevent overheating and arcing. The location is in Colorado, so you must take into account any local amendments to the NEC that may be in effect. Contact the local electrical inspector to inquire about any local amendments to the NEC. Also, ensure that the electrical system complies with all applicable building codes and regulations. Building codes and regulations may impose additional requirements for electrical installations. In addition to contacting the power company and tracing the source, consider hiring a qualified electrician to perform a thorough inspection of the electrical system. A qualified electrician can identify any potential safety hazards or code violations. The electrician can also perform tests to verify the integrity of the electrical system and ensure that it is operating safely and efficiently. Also, it is important to communicate effectively with all parties involved in the project, including the league officials, the power company, and the electrical inspector. Keep everyone informed of your progress and any issues that you encounter. Furthermore, document all of your findings and actions in writing. This documentation will be valuable for future reference and can help you avoid misunderstandings or disputes. Also, be prepared to revise your plans as needed based on new information or changing circumstances. Electrical troubleshooting can be a complex and challenging process, so it is important to be flexible and adaptable. If the press box is located more than 100 feet from the concession stand, there may be voltage drop issues to consider. Voltage drop can cause equipment to malfunction and can also create a safety hazard. Use a voltage drop calculator to determine the voltage drop in the circuit. If the voltage drop exceeds the allowable limit, you will need to increase the size of the conductors or take other measures to reduce the voltage drop. Furthermore, if the press box is located in an area that is subject to lightning strikes, consider installing a lightning protection system. A lightning protection system can help protect the press box and its contents from damage caused by lightning strikes. Also, if the press box is used for public events, you will need to ensure that the electrical system complies with the requirements of the Americans with Disabilities Act (ADA). The ADA requires that electrical outlets and switches be accessible to people with disabilities. In addition to the above recommendations, here are some additional tips for troubleshooting electrical problems. Firstly, start with the simplest and most obvious solutions. Many electrical problems are caused by simple things such as tripped circuit breakers or loose connections. Secondly, use a systematic approach. Start by gathering information and then proceed to testing and troubleshooting. Thirdly, be patient and persistent. Electrical troubleshooting can take time and effort. Fourthly, do not be afraid to ask for help. If you are not comfortable troubleshooting electrical problems yourself, contact a qualified electrician. Also, remember that safety is always the top priority. Never work on energized electrical equipment unless you are properly trained and equipped. Additionally, always follow the lockout-tagout procedures when working on electrical equipment. Furthermore, wear appropriate personal protective equipment such as safety glasses and gloves. Also, be aware of the potential hazards of electricity such as shock, arc flash, and electrocution. If you are unsure about anything, ask for help from a qualified electrician. To elaborate on this situation, the fact that the old press box was supposedly fed from the main service in the concession stand, but the new installation has a separate disconnect fed from an unknown source, presents a significant discrepancy. This raises concerns about the accuracy of the information provided by the league and the possibility of undocumented electrical modifications. The assumption that everything meant to meter box as well highlights the importance of clear communication and detailed specifications in electrical projects. Vague instructions can lead to misunderstandings and costly rework. The discovery of the 150 amp disconnect 20 feet from the concession stand is a crucial piece of information. This suggests that the press box is not directly connected to the main service in the concession stand, as originally believed. The fact that turning off the main breaker in the concession stand did not de-energize the press box further confirms this. The statement that the commercial rate for a separate service would be too expensive is a common justification for unauthorized or unconventional electrical connections. However, cost considerations should never compromise safety or code compliance. The 1/0 conductors are aluminum. Aluminum conductors have a lower ampacity than copper conductors of the same size. Refer to NEC Table 310.15b16 for the ampacity of aluminum conductors based on their insulation type and temperature rating. Also, consider the dilating factors for ambient temperature and the number of conductors in a raceway. Dilating factors can reduce the ampacity of conductors. Furthermore, ensure that the connections for the aluminum conductors are made with connectors that are specifically designed for aluminum conductors. Aluminum connectors are designed to prevent corrosion and ensure a reliable connection. It would be beneficial to create a detailed map of the electrical system, showing the location of all service entrances, disconnects, panels, and circuits. This map can be used for future reference and troubleshooting. The map should also include the size and type of conductors, the ampacity of the overcurrent protection devices, and any other relevant information. Also, consider using a thermal imaging camera to inspect the electrical system for hotspots. Hotspots can indicate loose connections, overloaded circuits, or other problems. A thermal imaging camera can help you identify these problems before they cause a fire or other safety hazard. It is important to address this situation promptly and thoroughly to ensure the safety and reliability of the electrical system. Failure to do so could result in property damage, personal injury, or even death. Furthermore, keep accurate records of all electrical work performed on the property. These records should include the date of the work, the name of the electrician who performed the work, a description of the work performed, and any materials used. Accurate records can be invaluable for future maintenance and troubleshooting.